What's up, YouTube? Bill's here, and today we are finally adding in all of that climbing functionality on moving platforms that so many people have asked for. That's right, you can grab ledges, you can climb up those ledges, and you can jump and climb on moving platforms while they go. So, if you want to learn how to implement this, let's get into the code. So the first thing I do want to mention is that there is a bug that I discovered while working on these mechanics. And that is, once you've edited a path here, you can't come back and change any of these things. So if I run this game again, let's see if it actually changes it. Oh, it did. Okay, so they might have actually fixed it, but yeah, literally 4.3 stable. It was not letting me make any edits to any of the nodes that were in the game. So it looks like now we can do that, and that's fantastic. So hopefully we don't run into that bug again. Alrighty, so first things we're going to do is we are going to go into our moving platform, and we're going to add a few things to this. So we've got our path progress right here. Perfect. We're going to add 4 vectors. So let's go previous platform position. And those of you who have been scoffing at my camel case, I have been practicing using better Godot syntax with snake case. I still hate it, but I'm trying to conform. So future videos, I'll probably be using that more, just because I'm trying to get with the program. Okay, so 4 vectors: previous platform position, so where it previously was, where it is, the velocity, and the extents. The extents are the shape, so the extents are like the width, so it's from the center to the edge. Those are the extents. They don't measure it in width and height, they measure it in extents, which is like length and height, but halved from the center. So that's what extents is, but we'll be using that for some stuff. Alrighty, next thing we are going to do, we're going to add in some functions that we're going to need. So the first one is going to be get position. That's going to return a vector 2, and it's going to yell at us real quick, so we forgot the C in func. Alrighty, and we're just going to return platform position. That's why return. There you go. Return platform position. Perfect. Okay. Alrighty. There's that. Next one we're going to do is function get velocity. Also going to return a vector 2. And we're just going to return the variable we have, platform velocity. And then function get extents. Sound it out. There we go. And that's also going to be a vector 2, and we're just going to return the platform extents variable that we defined earlier. And you're probably like, oh my goodness, I don't know what those extents are. That's okay. We're going to add that in right now. So in our ready function, after we resize the collider to the sprite, we're going to set the platform extents to be equal to our collider dot shape dot extents. Okay, perfect. There's that. And then in our process, we're going to add some more code, and we're going to use this to calculate our speeds and everything. So we're going to say if the platform position vector is not equal to the global position. So if we're not equal to the global position, then what we're going to do is Oh, let's get a yellow because that's not an equal sign. There we go. And why does it like that? Okay, so previous platform position is going to equal to platform position, and then platform position is going to equal to body dot global position, and then the platform velocity is going to equal the platform position minus the previous platform position, and then we have to divide this by delta, which we get from here. Alrighty. And we've got an air moving platform extends path to E as a global class script. Honestly, don't know why it's yelling at us for that. Is it yelling at us for that right there? It might be for that body position. There we go. Now it's not yelling at us. Interesting. Yeah, I don't have body in here, but that makes sense because the body is the actual animatable body. The path position doesn't change. The animatable body does, and that's what we care about. We want the platform position to be equal to the body global position. Alrighty, that's all done and dusted there. So why do we need these? So, well, actually, let's just go over this real quick. So, velocity is distance divided by time, right? So distance, where we are minus where we were, divided by time, delta. Delta is the time in between frames, and so that's how much we move between frames. That's why we divide by delta. And then what we're saying here is if the current platform position is not equal to the global position, so the platform has moved, but we haven't updated that variable, we set the previous position to be where this currently is, and then set this to be equal to where the body actually is. So we're always storing two positions so that we can calculate that speed. And then this just returns platform position, which gets updated here, and then the velocity, which we calculate here, and then the extents, which we get from right here. So we're going to need all three of those to really implement moving platforms. Alrighty, let's hop over to our player and let's add some variables that we're going to need. So we're gonna set that down there. We're gonna say variable moving platform offset. It's going to be a vector 2, and we're just gonna set it to vector 2.0 right off the bat. And then we have moving platform momentum, also a vector 2. Love vector 2s, use them all the time. Okay. Oh, sorry. This is jump momentum. My bad. And this one's going to be long. Moving platform corner grab position, also a vector 2. You don't have to type these, and by type I mean like say what type it is, like a vector 2 or anything like that. It's just good habit. Another thing you can do is you can do this little thing right here that I'll show you. So variable moving platform nudge, you can do this little operator. So the semicolon equal to, and what this is going to do is it's going to say, oh, this is an integer, so let's set this to integer, instead of like explicitly typing it. But we're just going to explicitly type it like that. And then player collider extents. Okay. That should be everything we need there. Come down to our ready function, and we're gonna set the player extents. So we need both the player collider extents and the platform extents, because let me pull up a sprite real quick. You can see everything I've been drawing. Alright, let's just create a new one. That sounds good. We don't really care about the size. Let's add some ground real quick. Perfect. Let's fill in the background. Let's add a new layer because we'll be moving stuff. We're gonna 2 layers. Alright, so this layer right here, this is our moving platform. Boom. And this layer right here, this is our player. Boom. So the way this works and the way we're doing this is when the player jumps and wants to grab, what we're going to do is we are going to calculate the offset. So like, let's say the center of the player is right here. We're going to calculate the offset. We're going to basically calculate this right here, this offset. So we know when the player's grabbing, the player should always be, you know, X away and then Y away. So then if the player climbs, you know, the X offset will never change. So it's changing right now, you know, because we drew this on this layer. So notice how the X offset never changes. But theoretically, you know, let's draw this a little better. Let's put this dot right here. Boom. Boom. Okay, there we go. Now we have it. So the X offset, you know, never changes when the player moves. So that's never going to change. But what will change is our Y offset. So when we climb, we just change our reference to be like, okay, our X will always stay constant, but the Y is going to change up and down when we climb the platform. And we're just going to lock the player into this offset position we have right here. And then we calculate this by getting the extents of the platform and adding on the extents of the player. So that's why we need those extents. So we add these two together, extents and extents, and that gets us our offset. So that's how we're going to be approaching this, and that's why we're getting a lot of these values. Okay, physics process. Okay, what we're going to do is, first we're going to say reset moving platform. And we're going to say if not moving platform, and we're going to say moving platform corner grab position will be equal to vector 2, not that, vector 2.0. So when we grab a moving platform, we're going to set this variable to whatever platform we grab so that we can access its, you know, location and all of that data. But as soon as we let go, we set this to null, and we want to reset this value. Otherwise, it's going to kind of snap our player around. It's going to be really buggy. So, yep, that's what we have to do there. Perfect. So now let's come down to our handle wall jump. I'm going to minimize all of these functions as we go down, just because we don't need them. Okay, handle wall jump, perfect. So this will all stay the same. We just need to add in, so if moving platform, so if a moving platform exists, that means we're grabbing to a moving platform. We say moving platform jump momentum is going to be equal to the moving platform dot get velocity. Else, don't forget your semicolon, moving platform jump momentum It's going to be equal to vector2.0. So just reset that. Okay, so that'll handle adding the momentum to our wall jump. Don't do anything there, don't do anything there. Close. Okay, and then we're going to add one more elif statement in here. So wall. Sorry, I'm just kind of scrolling through my example file and just adding in these little things that I know I'm going to forget unless I add them in now. When we get to like the meat of implementing the programming for grabbing the platforms, then we'll kind of be a little more focused. Right now I'm just kind of scrolling through. Okay, so wall slide. So wall sliding, I just kind of left it as is because with a moving platform, just hitting it, it's like it's sliding already. So I didn't implement it for that, just because it didn't seem like functionality that was really that important. You just need to grab a moving platform and climb it. So we left that be. All right, handle dash direction. Okay, so handle ledge grab. This is where we're gonna have some meat to do. So right here. Remember, we already added in this kind of check. And so this is where we are going to do some serious work. So first thing we need to do is actually set the moving platform, right? We keep referencing the moving platform, so we need to set it. And we're going to get this platform by getting the left lower ledge, because that's the one we use for collisions. We're going to say .get collider .get parent. So this is going to grab the raycast's collider, the thing it's colliding with, and getting the parent. Then we're going to set a quick variable called positional adjustment. Positional adjustment. And we're going to set that to a vector2. And so this is where we're going to set we're going to set ourselves up to that ledge, remember? So how we did this with grabbing kind of just any corner. So it's the moving platform get extents, right? And that returns a vector x. So we're grabbing the left side, so we want positive direction there. And then the negative of moving platform get extents y to shift us up. Because remember, negative y is up in Godot. Okay, and then keep that there, and then we are going to say moving platform corner grab position is equal to our positional adjustment. Additional ledge climb nudge is equal to resetting platform nudge. I honestly don't know how important that one is. I didn't really mess with it in the testing, but if it doesn't seem to be that important, you can try adding it or removing it, and if it breaks it, then it's probably important. Okay, and then we transition to state set ledge grab. Okay, so let's go over this. So get the instance, like the actual platform we're colliding with. Calculate the positional adjustment to be the positive extents, so from the center to the right, because we're grabbing from the left, negative extents y up. So that gets us all the way to the right and up to get us that top right corner, because that's where we want to be. We set the moving platform corner grab position variable to be equal to that, and then we change states to ledge grab. So all of this is just determining, how we're actually going to, like if we need to grab these things and then getting into that state. That's all what we're doing right now. Okay, so now we come here, and now we do the same thing. This one's spelled wrong. There we go. Okay. So now we do the same thing, but we grab the right lower, and then we do negative x, negative y, right? Because we're going to the left edge and then up to get the top left corner. So it's the same thing. We're just going negative x direction now. Okay, perfect. That's all good. Wall direction we don't need. So now the next big change comes here in get can wall climb. This is like the last function that we really need to change so that we can have everything we need to then go into the individual like moving platform states and adjust those to be working with the platform. So what are we going to do here? So we already have all these checks, and we set the wall climb direction equal to 0, right? So now we're actually going to change this, and it's actually quite simple. We actually set this to be so this will be, we set it to left, right? Because we know that this is the left side. And then we set the moving platform to be equal to the raycast that's colliding collider.getParent, right? And then in the else, meaning we're not colliding, we need to make sure moving platform is null. So we're literally just setting the moving platform here. So then this one's the exact same, but we're setting it to right, and then here we set it to null. And then moving platform equals null. Perfect. Yep. There we go. Alrighty. So that should be everything we need in just like the main player state. Now we need to go into the ledge grab and then ledge climb, and then I think we need to go into wall jump and maybe one or two other states. So let's go to ledge grab first, because that's where all of this will start. Alrighty, so we'll start with the ledge grab and the ledge climb states. Alrighty, and so what we're going to do is we're going to come down here to this enter state. Okay, and we've got this. So we're going to calculate a quick adjustment right now. So this, all of this right here is going to stay the same. And then we're just going to call this var adjustment, call it a vector2. And it's going to equal a vector2 of player, it's capital P player dot ledge direction dot x times -1, because we need to flip it, and then we'll set this to 6. And then we're gonna change this, and we're gonna say player dot moving platform corner grab position is gonna plus equals our adjustment. So that's gonna shift like the actual player sprite offset based on the actual corner position that we have calculated. Okay, now what we're gonna do is right here we're gonna say player dot animator dot speed scale equal to 1. And the reason we're doing that is along with this video next weekend, I'm going to release, I actually recorded myself like designing and coming up with this tutorial. I'm going to start doing that from now on as much as I can. And there is a massive bug where the animation speed gets buggy whenever the player climbs a wall, because we actually mess with the speed scale. So whenever we exit this state, we're just going to set that back to 1. Because the only time we really exit this state is if we fall or ledge climb. And if we ledge climb, we need this to be 1, otherwise it just stops working and gets super buggy. So that's why that is there. If you want to see a little more behind the scenes, once again, that video of me actually coding this tutorial will come out next week. Okay, and then we're gonna delete that, and then we're gonna say if player dot moving platform corner grab position is not equal to vector2 dot 0, meaning we do have a platform to grab, we're gonna set the player dot global position equal to, and then we're gonna get some parentheses started here, player dot moving platform dot get position, right? And then we're going to add on to this player dot moving platform corner grab position. We've got a lowercase player somewhere in there. There we go. Cool. And then else. So else meaning, you know, the moving platform corner grab position is 0. So there's not a there's not a platform or a corner to grab on a platform. Otherwise, we just set to like a normal grab position, just like that. Okay. And just making sure everything else looks good there. Alrighty, okay, so that's all good there. So now let's go into our ledge climb state. Okay, and we're going to replace this with this right here. And get rid of that. Let's grab ledge, grab final position. Ledge, grab final position. Man, this is just littered with errors, isn't it? That's hilarious. Bad code spelling on my part. Alrighty. Okay. So what this is doing is this is just going to give a little additional nudge, just to ensure that everything goes smoothly with our player while they're on there. And then it's honestly quite simple. We just say if player dot moving platform corner grab position is not equal to vector2, so this is just like the other state, vector2 dot 0, then we're going to say player, capital P, dot global position is equal to, and we're going to open up some parentheses, player dot moving platform dot get position dot, or actually no, sorry, we're not dotting that, plus player dot moving platform corner grab position. So just like that other one. And then let's see if we have to make any changes here. That looks the same, that looks the same, that looks the same, that looks the same, that looks the same. Perfect. All right, let's give this a test and see if everything works. It does not. Parse error, class moving platform hides a global script class. How did we fix this last time? We had to say like collider dot something, right? Oh, we have two moving platform scripts. What the heck? I am confused. Okay, which one is attached to our moving platform? Because that's all we care about. Yeah, it's this one. So there's a moving platform script with a space in our project. in file system. I'm going to click right there. Show in file system. So okay, let's close that. Open this. That's a different script. Okay, that script is broken. Remove it. We're actually doubled up here. What the heck? Get rid of that. I'm confused. Okay, let's delete that. Interesting. Okay, let's see what happens if we run this again. Okay, so okay, so all of those removing platforms. That is so interesting. Yeah, because this is the moving platform we want. Let's go to our world. Delete all of these. Now let's see if we can delete this. Perfect. Move this into platform types. Get rid of that. That is so weird. Okay, I don't know how I got doubled up there, but move that in here. Where are you? You're right. Oh no. Where are you? You're way up there. Okay, so let's move you. Atlas texture. Drag our tiles on here. Select the region. Perfect. Close that. That's all good. Scale the height to 5, speed, and let's add a curve. Here to here to here, back down to here. Cool. Okay, so now this is where we might have that glitch where it like won't work anymore. The one I was talking about a little bit earlier. So we'll see. All right, now let's try running this. Cool, we have a moving platform. And totally missed that ledge grab. Perfect. Okay, yep, so there we are. We're grabbing onto that ledge. We're hanging. We should fall soon. Yep, there we go, because the stamina runs out. Can we climb and then... Okay, yeah, so right there, it's going to crash because... Yeah, we'll handle that in a second. That was because we were kind of more going towards a climb state. Because we kind of have to come from above because climbing isn't implemented. And then can we climb? Nope. Crash on hitting that. Platform. There we go. Because remember we have that spelling error. Let's chill right here. Oh, missed it. Missed it again. Too good at this platforming thing. Perfect. All right, we can climb up top. Nice. Okay, so that's working great. So now we need to do wall grab, and then we can do wall climb. So let's go to our wall grab state. Okay, we're up at the top. Perfect, perfect, perfect. Okay, so now what we're going to do is down here, we're going to add in some more code. So we're going to say if player.moving platform. So is there a moving platform? If so, I'm going to copy and paste some variables. And we'll go over them, don't worry. So we're going to calculate the x offset. So this is how, remember with, we have this offset right here, and we talked about this offset, and we have this offset. We have to combine the player offset. We have to combine the platform extents and the player extents to get the x offset, and the same thing for the y. That's what we're doing right here. So getting the player, so we're getting the moving platform x extents, and adding the player collider extents. and then we're going to time that times the wall direction times -1. And so what that is doing is we're calculating the distance, and then we're setting it to, be plus, like the center of the moving platform, plus or minus, depending on which side we're on. And then we do the same thing for the y. So it's, well, the y we don't necessarily, the y is slightly different. We don't use the extents. What we actually do is we calculate the offset based on where the player grabs and the moving platform y. So by using their global positions, we get where the player currently is grabbing instead of like locking it to like one of the edges, if that makes sense. So we use the y in this case because if the player grabs up here, we need to calculate this y. We don't want the extents y. The extents y will put us right there. But if the player grabs down here, we want this y. So we're just calculating the difference in height between the player and the moving platform so it grabs accurately. And then, like I said, when we climb, we're just going to increase the offset or decrease the offset in that y position. And then, yeah, right here, we set that offset. So this is the key variable, the offset of where the player should be. Okay, so then in our update, we're going to add some code in right here. So first we're going to say player.get can wall climb, because we want to be updating those raycasts that we have. Now we're going to say if player.moving platform, so there is a moving platform, and if so, we're going to say player.global position is equal to player.moving platform.get position plus player.moving platform offset. So the player's position is always going to be whatever the platform position is plus this offset, which is what we just calculated up here. So we just need to keep updating the player like that. And then we have our climb, wall jump, wall release, animations, perfect. Let's make sure all this is the same. Yep, that's all the same. Beautiful. So now let's add wall climbing in. And so this one's going to get a little more involved. Climb direction is equal to vector2 dot 0. Those are all caps. I don't know why it's not auto-completing. I know why it's not auto-completing, because we have to say variable first. There we go. So we're going to store which direction the player wants to climb in this variable right here. This is all going to stay the same. And then down here, we're just going to say if player.moving platform. So once again, if moving platform isn't null, it means that we're grabbing a platform. So player.global position is going to equal to player.moving platform.get position, and then we're going to add that offset again, remember that offset that we calculated. And that's another reason we're storing that offset in the player script, so that we can kind of access it globally across states. Alrighty, so now we have all this code. We're going to say var speed equals 0, because we're going to have a speed variable now. And let's go through this one by one and see how this changes, okay? So this is going to stay the same. So if the player wants to climb, and the wall climb direction is not equal to 0, meaning that we are indeed on a wall, and if key up, and these are colliding, this is where we're going to change something right here. We're going to say climb direction equals vector2.up, and speed is equal to player.climb speed. Okay, and then we have our else statement here, and we're literally just going to switch this to be down. That's the only change that's going to go down right here. Okay, that stays the same, that stays the same, perfect. And so now we're just going to have one more condition down here. So if, once again, player.moving platform, for that semicolon, or that colon, I guess that's what that is. Moving platform offset is going to be added to a vector2. We don't want to change our x, but in the y, it's going to be speed times climb direction dot y times delta. Because previously we were setting the velocity, right? And so then move and slide, or move and collide, was taking into account delta. But now we're not using that velocity, or we're not setting the velocity, we're kind of manually doing this, so that's why we need to multiply by delta. And then handle climb movement is going to need a delta variable, which is a float, and then we just pass it in right here. So nice and easy. Yeah, we just pass that in. Else, so otherwise, and this is where normal climbing happens, we just set this equal to speed times climb direction dot y. So that's kind of how we had it before. And if you're curious, why am I using a vector2 when we could just use a variable? I like using vector2s. I know we're not going to climb in the x direction, but it's just kind of a good habit to be in vector2s. Alrighty, so now we are going to make some changes here. So let's delete that. And we are going to say if climb direction is equal to vector2 dot up, then we're going to set our player dot animator dot speed scale equal to -1, and then if, or elif, climb direction is equal to vector2 dot down, we're going to set the player dot animator dot speed scale equal to just +1. And the rest of that should stay the same. Alrighty, so let's see if this works. Also, Godot always does this where I hit like Z's and stuff afterwards, and it's really annoying. Get platform position does not exist. That is correct, because in my old code I had it as get platform position, but here I have it as just get position, because that makes more sense. Get that mouse out of the way. Woohoo! Okay, so we can grab, but when we climb, we crash. Yes, because mossing platform does not exist. That is correct. Okay, so now we can grab, and we can climb up, and we can climb down, and it works great. Wonderful. Look at that. Climb a moving platform. We can jump off a moving platform. Boom. Oh, that was fun. Ah, okay, yep. So this is a bug that I'll have to look through my code to figure out where to fix it real quick. But see how we keep snapping over to this moving platform. You see that? So that's because somewhere in our code, moving platform is not getting set to null. And so I get to play the fun game of going through all of the states real quick to see which states that we set moving platform to null in, and then I will go through and we can talk about which ones we're setting it to null in. Real quick, let's go to the jump state. I want to make sure that the jump state is up to date. Yep. That looks good. Yeah. I don't know if I've ever actually if I've talked about this, but the player.setSquish, if you notice when the player jumps, they kind of like get a little narrow, have like that little squishy effect. I just added that in there. I don't know if I explicitly told that, but it's just like a little visual effect that makes the player feel a little squishy when they jump. It looks good. Okay, so let's go to wall jump, make sure that everything is up to date there. That looks good. Oh no, we need to make some changes in here. Okay, glad I checked that. And then we'll go take a look at that bug. That all looks the same. Yeah, no, we didn't change those. Okay, cool. Okay, so what we're going to do is up here. Alright, so this is where we're going to set player.moving platform equal to null. So we're going to set that right there, and there'll be a few other places we do it. We're going to copy this because we're not going to use it. And we're going to say if player.moving platform hold on, this doesn't make any sense. This call needs to come after this, if that makes sense, because otherwise it's just going to always be null, and that doesn't make any sense. So then if player.moving platform jump momentum dot y is less than 0, player.velocity is equal to a vector 2 dot, and then I'm going to copy these in. So we're going to set it to the moving platform jump momentum x and y, the wall jump velocity. So we're just adding in the x momentum that comes from our jump, or that comes from the moving platform, sorry. And then otherwise we're going to set it to, so if the y is less than 0, meaning we're moving up, we're just going to set it to the x momentum. If it's not, then we're going to set it to the moving platform jump momentum plus the wall velocity. Does that make sense? So when we're going like down, then it doesn't like negate speed, but when we're going up, it adds the speed, if that makes sense. And then else, we're going to set this to player.velocity dot, or sorry, we're going to set the player's y velocity to just the regular jump velocity, because there's no moving platform, so we just jump normally. And then we're going to set moving platform to null. Okay, let's go to the fall state. Yep, the fall state, we need to set moving platform to null when we enter it, because we're obviously not on a moving platform. Wall grab. Okay, wall grab, we don't want to set it to null, because if we go from grab to climb, we still need that moving platform data saved. Same thing when exiting wall climb state, we don't want to set that to null, because if we go from climbing to just still grabbing, then we don't want to like reset that. Wall slide, we don't do anything in there. Dash doesn't affect us. Ledge grab, same thing, we don't want to set it to null. But ledge climb, I think you could probably set it in the exit state, but it's not like the end of the world. Okay, so we grab there, we come over here, land on top of it. Let's see if we can grab the side of it. Nope, I'm too good at this game. Okay, we grab it, we jump up, and now let's come grab something over here. Perfect. Grab there, grab there, grab there. Alright, yeah, so that should fix that. Springy, cool. We can jump, grab that, no problem. Missed that. Grab that, climb up, run, jump, climb up this, slide down it, wall jump. Perfect. Well, hopefully you've enjoyed this tutorial. I know a lot of people have been requesting this. I've kind of put it off because there's some other things I wanted to do, and I want to make sure that we really nailed this, and I think we have. So enjoy jumping and climbing on all of your platforms in your game. Hopefully you make some awesome games. If you're not subscribed to this channel and you've seen this video, please subscribe. We're trying to hit 1,000 subscribers as quickly as possible. Leave a like, drop a comment, share this with your friends that are also making platformers, and I will see you all in the next one.